We have been talking about hypothesis testing. There are various different kinds of hypothesis testing, and once you know the basic idea, the various different kinds are all sort of variations on that idea. So the one we're going to be talking about in this video is when you have a claim or a hypothesis about a proportion. What proportion or what percent or what fraction of some big group of people or things falls into some category. For example, let's say you have a big swimming pool filled with purple and blue beads. And you want to know if more than half of the beads in the swimming pool are purple. Now I'm using this example because it's easy to visualize, but it's similar to plenty of real-world examples, like instead of wanting to know if more than half of the beads in a swimming pool are purple, you might want to know if more than half of the voters in a state favor your presidential candidate. So, how do you tell if it's true that more than half of the beads in the pool are purple? Well, you could go in and count them all. Just go in, count all the beads in the whole swimming pool, count how many of them are purple, see if it's more than half. That would tell you for sure, but it might be very hard to do and take a very long time to count all those beads. So that's where sampling comes in. Instead of going through all the beads in the whole swimming pool, you could just make sure they're mixed up really well and then pull out a handful, a sample, and see if more than half of the beads in your sample are purple. So let's say you do that. First of all, how many beads do you pull out? Well, what if you just pull out 3 beads and it turns out that 2 of those 3 are purple? Well, 2 out of 3, that's more than half. Yeah, so more than half of your sample was purple. Is that enough for you to be able to say, well, more than half of the beads in the whole swimming pool are purple? Probably not. Because even if there aren't all that many purple beads in the whole pool, it's still possible that you could get 2 of them that you pulled out at the same time. So that's a really small sample size, and it doesn't really give you an idea of what's going on in the whole pool. You need more than just 3 beads. So next, let's say you pull out 100 beads, and it turns out that 51 out of those 100 are purple. Now, you've got a bigger sample. You've got more than half of your sample that are purple, but it's not very much more than half. It's just 51%. If things had just been a little bit different, say maybe 49 instead of 51, then it wouldn't have been half. If you pulled out a different handful of 100, it might not be more than half in that. So just from this, we can't say that more than half of the whole pool is purple. Okay, now what if you pulled out your sample of 100 beads and it turned out that 90 of them, 90 out of 100 are purple? So you got 90% of your beads are purple. And does that tell you that in the whole pool, more than half are purple? In this case, yes, it does. Because if that wasn't the case, if you did not have more than half of the beads in the whole swimming pool purple, then something like this would be very unlikely to happen. It technically is possible, but it's very, very unlikely that you would get this many purple beads in your sample if the number of purple beads in the whole pool was 50% or less. So in this case, we could say that, yeah, this is pretty strong evidence that more than half of the beads in the swimming pool are purple. So in this section, we're going to be doing hypothesis testing to be able to say, well, based on our sample, do we have enough evidence to support a certain claim, like that more than half of the beads in the swimming pool are purple. And it's going to depend on how big your sample is and how much more than 50% or whatever your claim is, how strong your evidence is. So this is going to be a lot like the hypothesis testing that we were doing in the last couple of sections, with just a couple of differences. It's like what we were doing before, but in step 1, where you state the claim and say what the null and the alternative hypotheses are, they're going to be about P instead of about mu. So for example, if your claim was that less than 10% of Lincoln College students have a pet tarantula, we could write that as P, the percentage or proportion of the population that we're talking about, Lincoln College students, fall into the category of tarantula owners. So this would translate into P is less than 0.10. So instead of being about mu, that mu is less than some number or greater than some number or equal to some number, it's about P. In this case, about P being less than some number. And so this would be your alternative hypothesis if you were actually going to test this claim. It's the alternative hypothesis because it does not have an equal sign. Instead, it has a less than sign. It's indicating a difference, that you're less than 10%. So the null hypothesis in this case would be the same thing, but with an equal sign. It would be that P is equal to 0.10. So that would be that it's not less than 10%, it is 10% or possibly more. And then the other difference in how we actually go through this is in step 2, where a different formula is used to calculate the test value, which you then go on to use to find the p-value. And then the rest of it works the same way as the hypothesis testing we were doing before. So in step 2, the formula that you use, well, if you're doing it yourself using the formula, or if you're using a graphing calculator function, or some other method, whatever method you use, here's what you will need to know to plug into the formula or put into the calculator or whatever. You're going to need the number that you are comparing P to in the hypotheses. In the example we were just looking at, that was 0.10. And if you're using a graphing calculator, it calls this P sub 0. In the formula we're going to use, it's just plain old P. You will need to know the size of your sample. N stands for the sample size. So how many beads you pull out in your handful, or how many college students you actually survey to ask them whether they have a pet tarantula or whatever. And you need to know either how many in the sample fit that category, like the actual number of purple beads in the handful, or you need to know what proportion of the sample fit the category, what percentage of your sample of beads were purple. So X would stand for the actual number out of N that fit the category you're talking about. And then P hat would be the proportion of the sample that fits the category. So that would be X divided by N. So then if you're doing this yourself with an actual formula that you plug numbers into and calculate the test value, here's what the formula looks like. Z equals P hat minus P divided by the square root of P times Q divided by N. So when you put this into a calculator, you're going to need parentheses around the numerator, and you're going to need parentheses around the whole thing that you're taking the square root of, so that makes sure that it takes the square root of that whole thing. The P hat in the formula is the proportion of the sample. So that would be how many purple beads you have in the sample divided by how many beads you have in all in your sample. The p is the number you're comparing p to in the hypotheses, and the q here in this formula is 1 minus whatever that number is for p. So if p is 0.10, q would be 1 minus that, which would turn out to be 0.90. And of course, the n in the formula is the sample size. So I'm going to end this video right here. Now that I've told you what's going on and how this works, I'm going to come back in the next video and work through an actual example so you can see how this actually works in practice.